All right.
Being a filmer.
Up here. All right. So we got lesson 4 notes, and I'm going to use your results to kick off this lesson. All right, and we'll go over some different terminology. All right. So notice here, I think this is Jared and Alex's graph. Notice here, you got force versus mass. What's the mathematical relation? In other words, what's generic? Is it exponential, inverse, linear?
Linear.
Yeah, this is actually a linear fit. They got a correlation of 1. That's pretty impressive. Might want to print that one out and put it on the wall. Anyway, so what they got here is force gravity equals 10. That's the slope. Newtons per kilogram times your mass. All right, let's see what other people got.
9991.
This one, who is this? This is Renato.
Yeah.
Yeah, here we go. All right, so how did your guys compare?
The correlation was pretty good.
Yeah, it was like,
good?
yeah, it was like,
Here in nature?
That's scary.
Real similar.
there's a little bump there. It's
All right,
on
let's take another one. What we got here? We got Henry and Zay.
Yeah.
How did you guys compare?
Ours has an excellent correlation.
Actual correlation, 0.9999. About the same slope. Linear fit. All right, let's do another one.
Our slope was huge. Ours was 10,000. But we did get a correlation.
No, it's cute.
Oh man.
I think it's cute.
Similar though.
It's cute.
Ready for that?
All right, there's Thomas, Griffins, and Jerry.
Good job, guys.
Very good.
Proud of you.
We also got the same slope. All right.
Look at that.
All right.
I won't be able to bring my Xbox.
Jerry. Every time I stop talking, doesn't mean you start talking.
I'm gonna shout.
Are you gonna let it all out?
All right, just because there's a void in the vacuum of the sound space around us doesn't mean you have to fill it. It means people are probably writing their notes down. I know you can do the same. I know you're excited because you haven't seen each other for a few days. But we need to do the lesson. All right. So, force of gravity is, on the object is proportional to the mass of the object. And that is the equation. Force gravity is equal to 10 newtons per kilogram times mass. What's that slope mean?
Every 10 newtons.
Yeah.
1 kilogram.
That's right. For every 1 kilogram of increase, what happens to the newtons? It goes up by 10. Okay, so meaning?
We did ours by grams, so that's why ours is so.
Yeah, as mass increases by 1 kilogram,
Force.
yeah, force gravity increases 10 newtons. It's a ratio of 10 to 1. It's about like the dollar to the peso. Right? It's an exchange rate. It's basically what it is, but it's linear like that. All right.
Oh, I got look.
I just really do some interesting things to keep stuff awake. Hey, I'm glad though. I'm not gonna do them now. Y'all look pretty tired. I know. You keep it. Hey, whatever it takes. If you guys stand up, that's fine. That's fine. You guys slap yourself in the face. That's fine. Don't care.
A or a Q?
Talking to your neighbor, not okay though. That one's not okay. Stay away. All right.
Is that a Q?
It's a G.
G?
Yeah.
G. All right. In textbooks, you'll see this equation as Fg equals m times g. G is represents the gravitational field strength. You get a different number by going to different planets. All right, so if you go to the moon, you're gonna have a force gravity of about 1/6 your value. All right, it's like in Space Jam, when the monsters come to Earth, right? They're totally dominating basketball. They can jump super high. They're super good. It's because the force gravity on their planet is so much greater. They got here. They're like, whoa, yeah. They're like all stars.
That's not.
No,
They're
that's
not,
not
not
right.
at all what happened.
That's
I
not
thought
That's the only legitimate explanation.
That is not at all.
The other is non-scientific.
They took basketball
out from it.
Space Jam really kicked off.
All right.
bad. You bad, they got.
There is a lot of bad science in Space Jam, and I'm not okay with that. All right, I just am not.
Basketball.
You completely put it on hold.
Here's what I'm saying,
That's not at all what just happened.
They stole them.
They stole it.
It's just like when you're on Space Jam, my comic might be
Like Piggy Pie defies gravity.
All right. Anyway,
I like how you made so many people mad by making that statement.
I don't know.
state the facts, people. All right. You cannot have a different opinion than me.
Yes, we can.
Okay? You can't. I'm not okay with that. All right. Anyway, this is on film. I totally was saying that in sarcasm. You don't understand that at home. Anyway.
Wait, what?
Anyway.
What
All
did I
right.
miss? I missed something.
So mass is not actually affected by the gravitational field strength. Most of your masses are between 50 kilograms and 120 kilograms in the classroom. All right. If you go fly to the moon and you're 75 kilograms and you get the moon, you're still 75 kilograms. If you go to Mars and it's 70% of our value of gravitational field value, you're still the same mass. All right. If you go to Jupiter, it's like, I don't know, 50 or 100 times greater than ours. All right, you're still the same mass. You just become a puddle, or you just become a smashed peat because your bone structure probably won't be able to support the force of that.
What do you mean problem?
Anyway, yeah.
So does like density get affected with gravity? So like iron is like denser in Jupiter
Well,
than it is in...
because density is mass. Is it mass over volume? Or is it volume over mass? Anyway, no, because if you change your pressure outside you, you'll change your volume. But other than that, no. Density won't be changed unless you change your pressure.
I do.
Silence. Zach. Be quiet. Thank you. All right.
I'm just curious because I'm American. Can you convert this for me just so I have an idea? Kilograms to pounds.
Oh, and then we're going to talk about that. It's
Okay,
a great
because-
question to ask because that's what's our next on our subject.
Okay.
I will get to that. I will get to that. All right. Force due to gravity is known as weight. In the English system, weight is measured in pounds. All right. So I'm going to go ahead and just put a couple of things. I would strongly suggest putting this down there. Force, gravity, or weight. Hang on to your question, guys, in the back. I think I know what it's going to be, and I'll get to it. Let me do this part of it. Force, gravity, or weight. Okay. The unit of measurement is newtons. And what do we measure that in? What do we use? What was our device to measure it?
Balance.
The balance is not what we measure this in.
Force sensor.
Scale.
Force sensor or scales. Scales measure that. All right. The M stands for mass. All right. And what's the unit for that?
Kilograms per
Right. Kilogram crackers, right?
Yeah.
All right. So we're gonna have a Fig Newton day for our weight. We're gonna have a kilogram cracker day for our mass.
That'd be awesome.
Right now, you can't believe how many people won't pass this quiz because you don't get these two things straight. And what do we use it for? What do we use it about? As a balance. All right. So, yeah, I strongly suggest you get this on a note card somewhere and get it in your mind because there's a major misconception. All right. Now, guys, what were you gonna say, Dan and Cameron?
I was just gonna say that your little Space Jam.
Okay, no.
Okay, no, no,
We'll talk
no.
about Space Jam in a second.
Well, like, have you ever
about
seen the
John
movie
Carter.
John Carter?
No.
All right, well that is more what you're talking about because he comes from Earth, to Mars, and he's able to jump really high.
But shit, the gravitational difference is like 0.7.
Well, it's not Mars.
It'd be like if,
some
like,
other-
Krypton, like Superman came from Krypton, where it's like 1,000 times stronger. So his body, you know, is under this like 1,000 times stronger, you know, pull, and he gets really strong, and he comes here and he's like, you know, has
If he
trouble.
didn't
Like,
strong, he was a baby.
I,
He wasn't lifted. No, he was lifted.
you don't live.
He was born the
He-
day before.
he gets his powers from the sun, actually.
Yep, he absorbed
Uh,
the
Superman died. Okay, there you go.
He came back to life.
Spoilers.
That was Jesus.
That
Stole the storyline, man. That was great. Believe me. Okay. I lived through the original Superman dying in the comic book. It was like I was like a sophomore in high school. Okay, and
Have you seen All-Star Superman guys?
and then like he comes back to life, and I'm like, that's lame. Done over,
He didn't come
whatever.
back in All-Star
Wait, how-
Superman. He was dead there.
He's bad. The robot guy was bad. All right.
But he came back.
Like, I
All right.
like Spider-Man.
know he does die and come back to life.
I know. I just got you all fired up again.
Yeah.
I just totally knocked on your two
Now,
favorite
now I want to
people.
read this comic. What
Space
issue?
Jam and Superman. So
What issue? I'm curious. Now I need to pick this one up.
And he didn't come back. He was dead.
all right.
Thank you.
Now
True
And
friend.
the sun was breaking. Use his own core to fix it.
I'm back. All right. All right. So one of the major misconceptions. You're gonna mess this up a lot. I'm gonna ask you for a weight, and you're gonna give it to me in kilograms. Here's why they have that thing. The scientific community's version of these is different than your non-scientific version. When you're in the weight room, you're pumping around. You got 2 plates on one arm. You know, and you got like what is that? Like 90 pounds plus the bar. You're like 90 pounds. All right, whatever. You got 2 on there. You know, like that. And I ask you the weight and the metric system. You're gonna give it to me. Was it 22.5 on the side of that?
Yes.
Okay, you're gonna say it's 45 kilograms.
So that's 90 pounds.
But that's wrong. If you give it to me the result like that, you're right. That's 90 pounds. You need to give me in the weight equivalent. Weight and mass are not the same thing. Weight would be you need to convert that to newtons. So it'd be about 450 newtons. It's about 450 newtons.
So we need to figure out the kilograms to find.
Just be careful. All I'm saying is just be careful. When you see the terms weight and mass, be careful how you convert them. They're easy points. Okay? I'm just throwing that out there. Now what we're going to do is several example problems. And then the rest of the class period you'll be able to work on the next worksheet. We'll go over that worksheet in class and then we're going to quiz it. Alright? We're going to have a quiz on it. It's just a one. Now, don't freak out. We're going to build on what we've already done. You're going to start these problems based on force diagrams and our logic. Now, all this equation does is it puts numbers to stuff. Because you do it with numbers, don't freak out. Alright, you'll be alright. Big, deep breaths. We'll get through it. Alright? This equation is much easier than our most equation. But don't worry, next unit we'll combine this equation with all the kinematics motion stuff. So don't worry. Just tell me.
Kilogram crack.
Don't worry, it's going to get 5,000 times harder.
I have 8 hours in a day.
What kind of food
Whoever said what? That was pretty funny. I agree. Anyway.
Hey, what are you doing? Whoa, whoa, whoa.
All right.
Hey, where's the hockey puck? I will gladly play hockey.
All right. For our first example problem. Remember the last?
But like when want to ask me, right? Essay.
Turned out
You just have a bowling
Alright,
ball.
5 kilograms.
You just have.
Here's the option you can take for the final. All right? Here's how you get out of the final. I'm going to line 10 of these balls across my room. I'm going to set them on fire, and if you can get through blindfolded without, getting set on fire or getting clubbed, I'll let you pass. You don't have to take the final.
I volunteer as tribute.
Don't just get them going like this. But I'll get them going like this. Here we go.
Just the whole
Volunteer.
The whole room. Flaming bowling balls and everything.
I'll do it.
It's making me nervous.
Volunteer as tribute.
I'll volunteer as a tribute for that.
There's just gonna be one
I'll
idea that
probably,
just flies normally
like-
if it's in the crowd.
Alright,
You shall.
now, if you're interested in doing a lab with this,
Hey,
take advanced physics.
all right. Well, I just figured I should do that. Right.
Oh, you solved the problem?
All right. No. All right.
Alright, so back to the problem.
All right. So will they all be about that height?
No, I'm gonna make them head height.
All right. Well, I'll just crawl on the floor.
Yeah, you can just go.
I'll make them different heights.
Oh.
They're all gonna be different heights. It's random. You can't see the course before.
Okay.
I'm so excited for this.
I'm totally kidding about the flaming bowling
Oh,
ball.
come on. I want to pass this final. Just quiz. I am a senior. Yeah, so it's like, I went.
Alright. So what we do when we start this, whenever we start physics problems, we do we have a set of things that we do. What's our first 2 steps? Now we're going to modify this for this new ideas. We always, when we get a problem in physics, we just jump to the end and try to solve it.
Everything you
Do
know.
what? Write down everything we know,
And what we're trying to find.
what we're trying to find. Dan, okay, knowns and unknowns, and then we need to draw a
Diagram.
And last semester we used a lot of graphs. This time we don't need graphs. We're going to use our force diagrams instead. I like to actually start with my force diagrams. You can do either. All right, so when we try to solve this problem, we start with the force diagram of the forces on that ball. So what's my forces?
Force gravity.
Force gravity on ball by Earth. Now, I'm not going to make you write the what's it by, all right? It's still there, and you'll be accountable for it on the test, but, you know what I'm saying, I'm dropping that part for this one. Okay, what else is on there?
Force tension.
Okay, force tension on ball by what? By the rope. All right. So, how do those 2 compare in this situation?
Equal.
Equal. How do you know?
There's no
Because it's not
acceleration.
moving.
At this time, please release freshman students to the NPR.
Freshman.
You're so funny.
I am pretty sure that Dan's a freshman.
Come down here.
No, I could. Yes, I could.
Basically, we just did a week's worth of physics right there.
Griffin and I.
Yeah, I know.
Okay?
That's pretty crazy.
Griffin, we can pass this freshman.
Week worth of physics right there. All right. So they're equal because of no acceleration. That's constant velocity, which 0 is a constant velocity. All right. So now we're going to do our knowns and unknowns. So we got an M equal to 5 kilograms. And what are we trying to find?
And
F T. I'm trying to find this guy right here. All right, now, does anybody have any ideas of how we could do this?
Never mind.
Renato.
Put the 5 kilograms in the equation.
Okay, put this in the equation. All right, so force gravity equal to 10 newtons per kilogram times 5 kilograms. It gives us 50 All right, now what?
Then,
Yeah.
because of the force diagram, we know that they're equal. So if there's 50 units, then it would have to be 50.
Yeah, brilliant. He goes, because, here's the logic he said. He goes, because the force diagram shows that they're equal, when we find force gravity, we found the force tension. See how it's a logic line? These are just logic statements. Thus, force tension. Now, the force gravity, if we get really technical, is probably a negative 50 because it's pointing down. It's positive, but it's not a big deal. I'm just introducing this. I'm setting up the stage for later on when it does matter. And probably next year. All right. Everybody good?
Yep.
Let's do one more.
Do we still measure like forces even if it's not gravity? So like I mean like if it's for example like if you're measuring gravity down as newtons, but if you're measuring you measure also the opposite.
Yep. Every force has anytime it's a force. All right, we got a trunk. That rests on the floor. Strongman Burns is trying to push it. He's got a stern look on his face because he can't. All right. Now, it's asking, what's the force of the push and what's the mass of the trunk? All right. So let's start off with a force diagram. We got, I'll do the easy one. I like the easy one. Force gravity, unboxed by Earth. Now, I didn't get out of that habit. I still said it, even though I'm not writing it.
Yep.
What else?
Force normal unboxed by Rose.
By Burns.
So we got force normal by surface. Okay, what else?
And then to the right, you got force normal on box by Burns.
So force normal by Burns.
And then in the opposite direction, force of friction.